The next question reads, find these expressions where A and B are vectors. Okay, so vectors are basically quantities with a direction and a magnitude. Okay, so the values that you see in a vector, so the regular notation for vectors are written like this. So let's say we have vector A. Okay, so vector A has an arrow sign noting that it is a vector, and that can be written out as a coordinate system where it's I, j, k with constants, or as a sum system like I plus j plus k. Okay, and you can have as many components as you want, and those components all contribute to the direction and the magnitude of the vector. Okay, so in this case, our vector A is equal to I plus 5j minus 2k. So the direction of this vector is noted by the vector being 1 unit in the I direction, plus 5 units in the j direction, and minus 2 units in the k direction. So if you were to have a axis planes with 3 different axes, you can really map out this vector for yourself. Okay. Another way to write this is writing it in the coordinate system, which is going to be 1, 5, and negative 2. Okay. So our second vector, vector b, likewise is going to be negative 4 units in the I direction, negative 1 unit in the j direction, and 5 units in the k direction. Okay, and these units are unspecified unless you want to specify them in a different way. And in the coordinate system, they're going to be negative 4, negative 1, and 5. Okay, so another important equation that we need to know, or another important formula, is how to calculate the magnitude of this vector. Okay, so the magnitude of the vector is simply, and the notation for it is an absolute value sign around your vector, is going to be the square root of I squared plus j squared plus k squared. Okay, and we're talking about the magnitude of each of the components squared and then square rooted. So that is how we calculate the magnitude. Okay, so now that we have these two formulas in mind, we can now try to solve each of these expressions. Okay, so first we have our first expression is going to be vector A plus vector B. Okay, so when you're adding together vectors or when you're subtracting vectors, you have to add each of the components or subtract each component separately. You're not adding them all together at once. Okay, so when we're adding vector A plus vector B, what does this mean? So A plus B is going to look like something like this. Okay, so if we had vector A here, and that corresponds to I plus 5j minus 2k, we're going to add each of the components separately. Okay, we're not going to add them all together. We're going to add them separately. Okay, so we're going to do this, and we're going to put an addition sign, and we're going to add them. Okay, so I minus 4I is negative 3I. 5j minus j is 4j, and negative 2k plus 5k is going to be 3k. Okay, so the vector a and plus b is going to be negative 3i plus 4j plus 3k. And let me just write this out in coordinate form just to keep the notation consistent. So that's going to be vector a plus vector b. Okay. So I'm just going to read it here. So that's the answer there. Okay, so the next one, we have 2 times vector A plus 3 times vector B. So when you're multiplying your vectors by constants, you're going to multiply each of your component by the constants that you have specified here. Okay, so in this case, we're going to first multiply our vectors by their respective constants, and then we're going to add them together. Okay, so we're looking at for 2A times plus 3B. Okay, so 2a is going to be equal to 2i plus 10j minus 4k. Okay, and 3b is going to equal negative 12i minus 3j plus 15k. And if we were to add this together, because that's what they want us to do, we would get negative 10i plus 7j plus 11k. Okay, so now writing this out here, we have negative 10i plus 7j plus 11k. Or in the coordinate system, we have negative 10, 7, and 11. Okay, cool. So now we're going to look at the magnitude of vector A, and like I said in our equation here, or our formula, this is how you calculate the magnitude of any vector. Okay, so for calculating the magnitude of A, we have to calculate the square roots of the squares of each component. So it's going to be 1 squared plus 5 squared plus negative 2 squared. Okay, so that's going to equal 1 plus 25 plus 4, and that equals 26 root of 30, and root of 30 is going to be that. Okay. That's the root of 30. Okay, cool. Now, the final question asks us to calculate the magnitude of A minus B. So, in vector mathematics, I guess you can say, you want to calculate the subtraction of the vectors before you calculate the magnitude. So that's what we're going to do. So first, we're going to calculate the subtraction of these two vectors first. Okay, so and on a side here, A minus B is going to equal, where's my two vectors? This guy is here. Okay, we're going to equal 5i plus 6j plus or minus 7k. Okay, so this is vector A minus vector B is going to be this respective vector itself. And then if you're going to square root that, we're going to have 5 squared plus 6 squared plus negative 7 squared. Okay, and that's equal to 25 plus 36 is 51 plus 49 is 110. 25 plus 36 is 51. No, 61 plus 49 is 110. Okay. So that means that the magnitude of vector A minus vector B is root 110. So this is how you do some of the vector calculations. It doesn't really account for the dot product or anything like that, but other than that, these solutions are correct. Okay. So these solutions are correct. Nice. Okay, moving on.